Hey students, it's me, Mr. Fitz. So I just wanted to make a video on the Desmos circle patterns activity and specifically this one problem that came up on the activity. And I wanted to show you some strategies. By the way, this was created by Kurt Salisbury. So shout out to Kurt Salisbury for that. Appreciate all the stuff he does on Desmos. So here's the problem. It's a circle equation question, and they don't always give you the circle equation. That's something you have to memorize. This x minus h squared plus y minus k squared equals r squared. Not sure why. They should probably just give that to you. So strategy one would be, well, I want to get the equation of this circle into this form. And notice that these equations here are not in the same form as this. This looks just like the Pythagorean theorem, right? It's like a squared plus b squared equals c squared. These do not look like that. So let's take a look. Well, the one strategy I have is going to expand the circle equation to make them look similar. So what is our circle equation? Remember, it's just a series of points equidistant from the center. And so the radius of this circle here is 4. 1, 2, 3, 4. And that's our r. R equals 4. There's the r in the circle equation. And then the center of the circle is 5, 2. So if I just count over 1, 2, 3, 4, 5, that's my x coordinate. Up 2, that's my y coordinate. So there's 5 and 2. So my h is going to be 5 and my k is going to be 2. Remember, we're subtracting those though, so it's going to be minus 5 and minus 2. So let's go ahead and write out the circle equation just by plugging in those values and see what it looks like. So there we go. There's our circle equation. X minus 5 squared plus y minus 2 squared equals 4 squared. So I want to expand this. And so this is just a squared binomial, 2 terms. And so some of you probably learned double distribution. When I was in school, they called it FOIL, first, outside, inside, last. But I'm a geometry teacher, so I'm going to show you the area model because I love area calculations. So I'm going to expand the circle equation using the area model. So here's how the area model works. So I'm going to take this first term here, this first binomial, and it's x minus 5. So this box is, the length is x. This is negative 5, x, negative 5. So what is x times x? That's going to be the area of this box. Well, that's x squared. What is negative 5 times x? So this is x down here. This is negative 5. Negative 5 times x is negative 5x. This is x. This is negative 5, so that's negative 5x. This would be negative 5 times negative 5, so that would be negative 5 times negative 5 is 25. So now I just need to combine like terms, and there you go. I've expanded this binomial here. It's x squared minus 10x plus 25. All right, so I want to do the same thing for this y binomial right here. So let's go ahead and take a look. If you want to pause the video and try it yourself, go ahead. But here we go. So it's the same process. I'm going to label these. So it's going to be y minus 2. So this box is y times y. This is negative 2. This is y. So it's going to be y times negative 2, y times negative 2, and then negative 2 times negative 2. So what do those equal? Y squared minus 2y plus 4y. We can combine like these like terms because they have the same power. That's raised to the second power. That's raised to the first power. That's actually y to the 0th power, believe it or not. So we can combine those terms. And there we go. I've expanded the circle equation. Oh, I'm missing it's not an equation yet. Now it is, it has an equal sign. 4 squared is 16. So there we go. I've expanded it. Now I can combine these like terms, right? If I wanted to, I could say 25 and 4, that's 29. But notice like there are no constants over on this side of the equation. So actually what I really want to do is just move these over to the other side of the equation. How do you do that? Well, what operation is happening here? Addition, addition. Opposite of addition is subtraction. So I'm going to subtract 25 from both sides and 4 from both sides. What does that leave me? X squared minus 10x plus y squared minus 4y equals negative 13. Winner, winner, chicken dinner. There's our answer. All right, so that's our answer. I thought this method was pretty clever, and it was a nice way to think about it. So we're going to look at another strategy next, and so let's take a look. So let's take a look at this second strategy. And this strategy is really useful for questions when they just give you the circle equation in this form and they ask you for what the center and the radius is. And so it's usually a trick question where they're trying to like fool you like, oh, there's the radius, right? No, it's not in this form yet. So remember, we need to get it in this form to figure out what the center and the radius are. So that's when we need to use completing the square. So I just wanted to show you this strategy. For this problem, you'd have to actually do it for all four of these to just figure that out. It is a method you could do. It's a little more time consuming, but you can definitely do it. So I'm just going to focus on the one that I know is the correct answer and show you how to do it. That way you can see how it's done. So let's take a look. Completing the square. So I'm just going to write this equation like this. So it's x squared minus 10x with a little space, and then y squared minus 4y with a little space, and that equals negative 13. So how completing the square works, I'm just going to use this area model again. And so x times x, that's my x squared term. And then my negative 10x term is right here in this rectangle. So what I'm going to do is I'm going to take this negative 10x and slice it in half. And I'm going to move half of this rectangle down here. So I could write that as negative 5x minus 5x, but you don't have to. So I'm just slicing that in half. And there, that's how it looks, just like that. And so now I have negative 5 times x in this rectangle and negative 5 times x in this rectangle. Fundamentally, I haven't done anything. I haven't altered the state of the equation or anything. I haven't done anything crazy. I've just broken that term into two equal pieces. Now, what I want to do is I want to complete the square. And how I complete the square is like I need to fill in this little gap down here. So here, look. So now I have this orange square. I'm just missing this piece. So what is the area of this little square down here? Well, the side lengths are negative 5 and negative 5. So what is negative 5 times negative 5? 25. And that's what I'm going to add to both sides of the equation. So I've completed the square for this term here. And so if I add 25 to this side, I have to add 25 to this side. Remember, an equation has a balance. So I can do that. And I'm going to show you what you have to do after that in a second. All right, let's do that same thing for the y terms over here. Here we go. So it's going to be y squared and then negative 2y, negative 2y. Remember, I'm cutting this term in half. So it's negative 4. Negative 4 divided by 2 is negative 2. So it's going to be negative 2y, negative 2y. And I'm going to complete the square. Well, that's 4. Negative 2 times negative 2 is positive 4. So there we go. I've added 4 to both sides of the equation. Now what do I have to do? So why it's called completing the square is because these are square terms. If I factor this, if you want to go back and look at how we factor, you can say that this is going to be x minus 5 squared. Look, it's already in factored form for me, right? X minus 5 times x minus 5 is this whole area here. So that's why I really like the area model, because it's already in factored form for me. So x minus 5 squared plus y minus 2 squared equals, and what is all this combined? 16. And if I want to check that, what I can do is say x minus 5 times x minus 5. That gets me back to this. So if I factor that, that's exactly what I'm going to get here. So I just wanted to show you the area model because you don't have to do any factoring. It gives you the factored form already. So there's my y minus 2. There's my x minus 5. There you go. And once you get used to like doing this, you'll see the pattern. Notice here, like what did I have to do? I had to divide this negative 10 in half, right? Negative 5. Look, x minus 5. I had to divide this negative 4 in half. Look, negative 2. All right, so that's, once you like start doing this a lot, just remember you have to add that 25 and the 4 to both sides to figure out what the radius is. And so what's the radius going to be? 4, because that's 4 squared. So there's the center, 5, 2. There's the radius, 4. Okay. All right, I'm going to show you one last strategy. This is my favorite strategy, actually the one that's coming up. So let's take a look. Okay, so this is my favorite strategy. It's actually a little guess and check, but it's more of an educated guess and check. So what do I mean by that? Yeah, educated. So what a circle is, right? It's just a series of infinite points equidistant from the center. So if we can think about it as like all these points are the same distance from the center. And so it's just an equation, just like a line would be like a series of coordinates that satisfies some equation, right? So we can represent a line on the coordinate plane or a circle. So all of these points would have to solve the equation. So if I just pick one, and if you have to be really careful, is make sure like it's intersecting on one of these like sections where they're integers here, whole numbers. You don't want to pick like a fractional coordinate. So I'm going to pick one that has really low numbers. I'm going to pick this one over here, 1, 2. And then so what do I have to do is just plug in the x coordinate 1 for all of the x's and the y coordinate 2 for all of the y's. So this is a little less algebraic than what we were doing before. That's why I kind of like it. So if I plug in 1, so I'm just using this first one here for x, and 2 for y. So what do I end up with? 1 squared plus 10 times 1 plus 2 squared plus 2 times 2. Does that equal negative 13? I don't know. Let me expand that. Let's take a look. 1 squared is 1. 10 times 1 is 10. 2 times 2 is 4 plus 4. No, that all equals 19. Definitely does not equal negative 13. So this first one is out. All right, let's try the next one. So it's more like plug and chug and guess it instead of guess and check. But and it's not random guessing, right? I'm not just plugging in like random points to figure it out. I just want to see like, and you could try one of these other points too. That would also work. So x squared. So 1 squared minus, so this is the difference here. This is negative 10x. Minus 10 times 1 plus 2 squared minus 4 times 2. Does that equal negative 13? Well, let's take a look. 1 squared is 1. And yeah, that all works. All right. Winner, winner, chicken dinner. There's my answer right there. Victory. So let's go ahead and circle that. All right. So I hope this helps. Please let me know if you have any questions. And thank you so much for watching. I think there are going to be quite a few bloopers on this one because this one took a while. Anyway, again, thanks for watching. Bye. Hold on. And that's going to equal 16. Whoa. Hold on, Mr. Fitz. That went a little too fast. All right. Actually, I didn't want it to go that fast. Why did it do that? Oh my God. What was I doing?